Let's talk about dynamic memory allocation. Now, before that, let's try to see some of the limitations of static memory allocation. Well, the size cannot be increased at the time of execution, or the size cannot be changed. Also, we cannot delete any item, or we cannot free any memory which is allocated using static memory allocation. Let's suppose that we have declared a very large size static array and we will try to use only a little bit space. So it's basically a hell lot of waste of memory. So how we can overcome this problem? To overcome this problem, we can use dynamic memory allocation. So it's the technique to allocate memory at the time of execution only. Now, if I can consider the given memory for a program, it can be divided into two logical sections. One is the stack section, another is the heap section. So stack section is basically given for the static memory allocation, and heap section is given for the dynamically allocated memory. Now, from the stack section, whatever we allocated will automatically be freed after the execution, but in the heap section nothing will be freed after the execution. It will remain on the heap section. That's why it is also called garbage. So it's the duty of the programmer to free all of those dynamically allocated memory manually. And another thing that should be noted, C and C++ has no garbage collector. Let's try to discuss how we can dynamically allocate memory in C. There are four functions for managing a dynamic memory allocation in C, and they are malloc, calloc, free, and realloc. So what does malloc function do? In malloc function, we need to pass the size in bytes, that how many bytes of memory we want to allocate. So let's try to use this malloc function. So I will be giving the size of int in these functions. So what the size of operator will do, it will just simply return the size of the integer data type, and malloc will allocate that amount of bytes. But how to reference that location? To reference that location, we need to store this into a pointer that can point to that allocated location. So let's declare an int pointer arr. But there is a problem. Malloc returns a pointer of type void, which is generic pointer. If you don't know about void pointer, let me just tell about this. Void pointer is a pointer that can point to any type of data. But here int asterisk arr, this can point to only type of integer. So we need to convert this data type. So we are going to typecast this into int asterisk, that is integer pointer. So one block of memory is allocated and this array is pointing to that location. What will happen if you want to store multiple blocks? So if let's say that we want to store n elements, that is the array. For that purpose, we will be just writing n and this multiplication operator here. Let's talk about the calloc function. Well, calloc function is almost same, but it takes one extra argument, that is the number of identical blocks we want to allocate, and it also takes the size of each block, and also we will have to typecast this because it also returns a pointer of type void. But there is another difference. Let's try to see what's the difference. So here I have defined a function called print array. It is taking two arguments. One is the pointer, another is the integer. So we will be passing all of this dynamically allocated memory with the size. I'm going to just print all of those elements of the array. So you can see here that I'm just using arr in between square brace. I'm writing I. So I'm basically using it as an array because all of the items are stored in consecutive memory locations, because malloc and calloc is giving a consecutive block. So I can use that as an array, but I can also use, instead of writing arri in square brace, I can write like this asterisk arr plus I. But you may be thinking that why I'm not writing arr plus the size of the data type multiplied by the index. Well, this is not a simple arithmetic, this is pointer arithmetic. So if we write this arr plus I, it is same as arr plus size of int multiplied by I. So but as it is a pointer arithmetic, we need not to write that here. So this will give the address of the ith element, and we are just saying this asterisk means value at that location. Let's try to compile and run this code. Well, you can notice that the first array is allocated using malloc and the second one is using calloc, but in the second one all the items are 0, but in the first one there are some garbage random values. So this is the basic difference between malloc and calloc. Calloc not only allocates the memory, also it initializes the allocated memory by 0. If you are allocating the memory dynamically, you must have to be careful about one thing, that you always try to free the memory manually. So we can use this free function. It will take the pointer and it will return the memory that is allocated dynamically. In C++, we can use this new keyword to allocate memory dynamically. It will allocate a single block of memory and it will return the address of that allocated block. So we can also free this allocated memory using this delete function. We can also write delete in this way. Now, what would happen if we want to allocate multiple blocks? We can take the size from the user. So for this purpose, we will have to mention the size in between these square braces. And after that, we can delete multiple blocks using the square braces after delete keyword. How we can allocate memory for 2D arrays? Well, there are many ways that we can do this, and the simplest way to do this is to use an array of pointer. So what is an array of pointer? Array of pointer is same as array, but in the case of array of pointer, each of the element of that array of pointer will store an address rather than some value. So we can iterate through each of the elements of the array of pointer, and then we can dynamically allocate the memory. That would be equals to the size of number of column, and then we can assign that allocated address to each of the element of this array of pointer. So it's obvious that the number of rows is equals to the size of the array of pointer, and C is the number of columns that we would have to mention at the time of iteration. Let's see an example. So here I have declared an array of pointer which can store at a maximum of 100 rows. So what I'm going to do here, I'm going to iterate through each of the elements and allocate the memory. So I will be using the Gallup function. So I will be assigning the allocated address like this. So Gallup function takes two parameters. One is the number of blocks that we want to allocate. That should have to be equals to the number of column, and size of the data type, that is the int. Let's try to take input from the user. After the allocation, we can use it as a 2D array. And now let's try to print elements. But after using this array, we must have to free the allocated memory. But we cannot simply pass this in the free function because it's not a pointer, it's an array of pointer. So what we can do here, as each element of this array acts as a pointer, I can just iterate through each of the elements. I can pass it in the free function. That's how I'm doing right here. Now let's try to compile and run this code. But there is a problem in this method. You can see that the number of rows is fixed. So we need to give the number of rows at the time of execution, so it's not fully dynamic. So in my next video, I will be showing you other methods for doing the same.